What is a zero of a polynomial? Well, a real zero of a polynomial is a value in which you take your function and you evaluate it at that value and you get back 0. If that happens, we would say that value, let's call it a, is a 0 of the function. And in particular, if that value is a real number that's in the domain of the function, then it's a real 0 of the function. So from a graphical perspective, if you think of your Cartesian coordinate plane, since we're talking about real zeros of a polynomial function, imagine that you have a polynomial that's like a smooth continuous curve. Wherever that polynomial crosses the x-axis, that's where your function is 0. So those values, those x-intercepts, are the zeros of your function. So for example, let's call this the value, let's say this is at -3 and maybe this value's at 6. Then we would say that -3 is a 0, and we would also say that 6 is a 0 of our function. And then simultaneously, if you know the zeros of a function, you automatically know the factors of the polynomial. So for example, if -3 is a 0, then x minus that -3 is a factor. And if we simplify that, we know that is x plus 3 is a factor of the polynomial. And in the same respect, if a equals 6 is a 0, then x minus that 6 is a factor. And so I'll just list it again over here. So we would say that x plus 3 and x minus 6 are factors of our polynomial. Now, a polynomial, as we know, has a certain degree, so the highest power of the polynomial. So let's say we consider that we have the function f of x equals x cubed plus x squared minus 6x. So we would know that the degree of this polynomial is 3. Well, what that means is, as far as zeros are concerned, that the maximum number of zeros that this polynomial could have is 3. In other words, the maximum number of times this polynomial can cross the x-axis is 3. It could be less than 3, it could be equal to 3, but it could never be more than 3. And so that is always the case. Your degree determines the maximum number of zeros you could have. So in order to determine those zeros, we use certain techniques. So one technique that we would use, let's say that we had a polynomial that was quadratic, so degree 2. We could use the quadratic formula and solve that, and what we get for our x at the end, those would be considered our zeros of our polynomial. Another method that we can use, aside from the quadratic formula, because we're not always dealing with quadratics, is our methods of factoring. So this could be if you have a greatest common factor, it could be reverse foiling, could be the method of grouping. All the factoring techniques you've learned about in the past you could use to help factor your polynomial down so that you could get your zeros. And so what you would do is you would factor your polynomial down, and then you would set each of those factors equal to 0 to determine your zeros. So for example, if we take the polynomial that I have here on the screen, f of x equals x cubed plus x squared minus 6x, and we go ahead and factor it, the first thing I would notice, all the terms of this polynomial share a common factor of x, so I would factor that out first. And so if I take out an x from each term, that means I'm dividing it out. So x cubed divided by x is x to the second. X squared divided by x is x to the first. And -6x divided by x is -6. Or another way to think about that is, what do I need to multiply x by to get x cubed? The answer is x squared. What do I need to multiply x by to get x squared? The answer is x. What do I need to multiply x by to get -6x? -6. And so this is part of the factorization, but then we need to go further because what's remaining in parentheses here is quadratic, so it may be factorable. So if I ask myself what two numbers multiply together to give me -6, but then add together to give me a positive 1. And so if you think about that, you could think, oh, well, I think positive 3 and negative 2, because positive 3 times negative 2 is negative 6, and then 3 added to negative 2 is positive 1. And I'm like, okay, so then I can go ahead and factor this quadratic down into x plus 3 and x minus 2. And that is the complete factorization of f of x. So then from there, what you would do is you would set each factor equal to 0 and solve for x. So I would set x equal to 0 because that's the first factor, x plus 3 equal to 0, and x minus 2 equal to 0. And then just solve for x. So in this first case, x equals 0, the x is already solved for because x is already by itself, so that's done. In the second case, I need to subtract off 3 from both sides of the equal sign, and that gives me x is negative 3. And then I need to add 2 to both sides for this third case, and that would give me x is a positive 2. So we would say that the zeros of our polynomial f of x is the set 0, negative 3, 2, which means this is where our graph would cross the x-axis at 0, negative 3, and 2. And this also means that f evaluated at 0 is 0. F evaluated at negative 3 is 0. And f evaluated at 2 is 0. So that's using the method of factoring to help us determine the zeros. And then sometimes factoring doesn't work. And we would use what's called the intermediate value theorem to determine our real zeros. We won't do that as much in this class. I will definitely show you how to do that. But basically the idea is if you have two values, and you take your function and evaluate them at those two values, and one of them comes out to be positive and one of them comes out to be negative after you evaluate, then what that means is there's some zero in between those two values for which your function is 0. So in other words, there's a 0 in between those two values if you evaluate at them and one of them comes out to be positive and one of them comes out to be negative. So in conclusion, hopefully that gives you a better understanding of what a zero is graphically and also from a polynomial factored perspective, and just knowing the different techniques to help you determine what a zero is. So that goes ahead and completes this lesson.